In this video, I want to step you through the solution for the HOA program for the color sorting conveyor. HOA stands for hand-off auto. Quite often in manufacturing automation, we need to program a control panel so that an operator can put it in manual mode and activate or deactivate certain aspects of the machine to clear a jam or to do some troubleshooting. It also needs an automatic mode so that the machine can just run automatically. So that's the intent of this assignment, is to help you learn how to create those types of programs. Let's go to the global variables area and notice all the global variables that I've set up. You'll notice that there are Boolean variables from number 0 all the way to 14. Boolean data types are simply ones or zeros, just a bit, an on or an off. There are also these three inputs here that are integer inputs. And notice I've set that data type to an integer. There are also some Boolean outputs. Again, the data type is Boolean. It's a bit, either a 1 or a 0, an on or an off. And I also have three outputs here that are set to double integers, dint. The difference between an integer data type and a double integer data type is the number of bits that can define the integer. A single integer is defined by 16 bits, and a double integer is defined by 32 bits. Now let's go to this color sorting program. It's a ladder logic program, and you'll notice that I have put labels on specific rungs. Rung number 1, I've just labeled the select, auto, and manual. That rung allows the operator to select between automatic and manual mode. It's a selector switch. A 0 would be manual mode, and a 1 would be automatic mode. And you'll notice on the rung that if the selector is a 1, I get continuity, which will jump the program. This is a jump instruction right here. It'll jump the program to the rung labeled automatic mode. So if I scroll down, you'll see that rung number 7 is where the automatic mode begins. So if the operator has selected automatic mode, it'll skip over all the manual mode rungs, jumping to the automatic mode. Now as I scroll down even further, you'll see that I have rung 14, which is labeled counting. These rungs are where it simply senses whether or not an object has passed the shoot 1 sensor, shoot 2 sensor, or shoot 3 sensor, and will count up the number of parts that have passed those sensors. So let's scroll back up, and I want you to pay specific attention to rung number 6. Rung number 6 is also a jump instruction, and that's important. Let me explain why. If the operator has the selector switch in manual mode, then rung number 1 will be false, and the jump to automatic mode will not happen, and we'll move into this rung 2, which is the manual mode. And we'll run through the manual mode rungs. And because a PLC simply scans all the lines of code over and over and over again, if we're in manual mode, we certainly wouldn't want to scan all the manual mode rungs and then just keep going into the automatic mode rungs, which is why number 6 at the end of the manual mode also needs a jump instruction, which will skip over the automatic mode and jump right down to the counting rungs. Let me show you how to actually add one of these labels. If I simply come to this rung, right-click, I can choose to display a label. And then when I double-click in the label, I can type the name of the label. Now it's important to note that these labels cannot have any spaces. They can have underscores, just no spaces. So this rung number 7, I just right-clicked, chose to add a label, and typed in the label, automatic mode. This jump instruction is right here, the jump instruction. So I just drag that in, and then I can type the label that I want that jump instruction to jump to. Let's take a look at each rung in detail. Rung number 2 is in manual mode, and it allows the operator to start and stop the conveyor. This rung is a very typical seal-in rung, which means I can push the start conveyor button and let go, and the conveyor will continue running. So when I start the conveyor, I get continuity because the stop conveyor button, by the way, is a normally closed contact. So it will have continuity when nobody's touching it. And on the right side, you can see that when I do have continuity, I'm turning two outputs on, both the conveyor running light and the conveyor motor. And I seal that rung in so that when the operator lets go of the start button, it continues running because I have this parallel branch that detects if the conveyor running light is on. And if it is on, it'll stay on. And you can see rung 3, it's the exact same logic as rung 2, except for with the arm. If you push the button to activate arm 1, I'll get continuity, and it will turn on 3 outputs. The arm 1 running light, the arm 1 pivot, and the arm 1 belt. And those will stay on because I've sealed it in with this branch here Rung 4 is the same thing, but activating arm 2, and rung 5 is the same thing, where the operator can manually activate arm 3. Now let's go to the automatic mode. Rung 7 is the first rung of the automatic mode, and it's just the typical seal-in rung that will allow the operator to push the start button and release it and have it be running. Rung 8 is simply a comparator. It reads the integer sent by Vision Sensor 1, compares it to a 7. If it is a 7, then it will turn on the arm 1 pivot and the arm 1 belt. And notice those are set coils, so that they will stay on until they are reset. Rung number 9 checks to see if the chute 1 sensor has been tripped. And if it has, then it will reset arm 1 pivot and arm 1 belt. Now this chute 1 sensor will reset those outputs as soon as the sensor is triggered, and I probably want to wait until after the sensor is finished being triggered. So I'm going to right click on this, go to the Properties window, and instead of having a direct contact, I'm going to put in a pulse falling edge contact, so that it won't provide continuity until after the sensor is finished detecting. That way the arm will not be reset and turned off until after the part has completely passed by the chute 1 sensor. And you'll see rungs 10 and 11 are very similar, so I better change this one to a falling edge pulse contact. And then rung 12 and 13 are the same. Vision Sensor 3, comparing it to a 1. If it is a 1, that means it's blue. So we set arm 3 pivot and arm 3 belt. And I'll change this contact to a pulse falling edge contact as well. And then rungs 14, 15, and 16 are simply just the counting rungs. If chute 1 sensor sees a part, it will count up by 1 and report it out to this DINT_OUT0 variable, which is the gray total, and sent to that digital display. Same with rung 15 is checking for chute 2 sensor, counting up the green total, and rung 16 is checking the chute 3 sensor and counting that up as the blue total.